Hi, and welcome to day 5 of Trig Graphs. Today it's actually going to be very simple. We're graphing the tangent curve. The tangent curve is a discontinuous function, which means unlike the sine and cosine curves, it's not one smooth wave that continues on and on. It's always increasing left to right. We have undefined values called asymptotes, and if you remember when we were filling in our charts, we had those little u's or little undefines. That's where we're going to have asymptotes. What that means with your graph is you can get as close as possible but not touch the line. And we always write or draw where the asymptotes are located with a dotted line. That should be butt number. All right, graph y equals tan x using on the interval negative 2 pi to 2 pi using 45-degree intervals. Remember 0, 45 degrees, 90, 135, 180, 225, 270, 315, and 360. I remember how to count by pi over 4s. 0, pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2, 7 pi over 4, and 2 pi. The tangent of 0 is 0. The tangent of 45, we know from our special right triangles, is 1. The tangent of 90 is undefined. The tangent of 135, if we would find our reference angle, since my radians is pi over 4, my reference angles would be 45. Tangent of 45 is 1, and I'm in quadrant 2 when I'm at 135 degrees. That makes tangent negative, so that makes this a negative 1. Tangent of 180 is 0. 225, again, we use a reference angle, which is 45. In quadrant 3, tangent is positive, so this is 1, because the tangent of 45 is 1. 270 is going to be undefined. 315, I have to find my reference angle again, which is 45. I'm in quadrant 4. Tangent is negative, so it's negative 1. And then 360 is back to 0. So at pi over 2 and 3 pi over 2, my graph is undefined. So I have my asymptotes there. My asymptotes are vertical lines that are just dotted. And we have another one at 3 pi over 2. And tangent is just like the sine curve in that it reflects through the origin. So that means we'll have another asymptote at negative pi over 2 and negative 3 pi over 2. I have the point 0, 0. Pi over 4 is going to be halfway between here. So that's where my 1 is. Pi over 2 is undefined. And then halfway in between pi over 2 and pi, I have a negative 1. At pi, I have 0. And halfway between, I have a positive 1. We have a negative 1, because at 3 pi over 2 are undefined. Then my next point is negative 1. And then 2 pi is 0. How I draw the tangent curve, I kind of imagine drawing a paper clip and unfolding it. And that's kind of what the tangent curve looks like. You don't have to label all of your lines, but 1, y equals tan x near one of your curves would be nice. Since it reflects to the origin, that would make this negative 1, and it's going to continue down. And then if you see this pattern, it's going over and over again. So at negative pi, I'll be at 0. Here I'll be at 1. Here I'll be at negative 1. So we draw our curve, and now this curve, negative 2 pi, I'm at 0, and then I'll be at 1. It's going to kind of go up like this. So it's the same pattern over and over and over again. Okay, it looks like a bunch of, actually, x cubes graphs, what it looks very similar to. But imagine a paperclip and unfolding it, and then you just keep repeating that. So there is no amplitude because it goes up in the positive direction and down in the negative direction. So there's no amplitude when we talk about tangent. It doesn't affect the graph as much as you would think. The only thing the amplitude is going to do is make your curves either thinner or wider. The domain is all real numbers except for odd multiples of pi over 2, and that's where our asymptotes come into play. And the range for the tangent is actually different. Unlike sine and cosine, you have a maximum value and a minimum value. Here we don't, therefore our range is all real numbers. And that's really all there is, just graphing just the plane of a tangent function.